Hello everyone, welcome to another video. In this video, I'm going to show you how to deploy a 3-tier application in an AWS EKS cluster. And right now on my screen, you can see there's a resource map. So this is the entire application resource map, which means that whatever resources I'm using, along with that, how the traffic is being routed from user's browser to right down to the database. So I'm going to explain that part as well. So in this a particular application, do not focus on the application part much. It is about how to use the different components of Kubernetes to design and deploy an application, specifically 3-tier application, and also to understand the entire traffic flow that's going to happen in this type of application. I'm going to share the entire code that you can use to do this hands-on demo yourself. So I'll be sharing it in a GitHub repo. Okay, so let's get started with this application. So whenever any user accesses this particular application from his or her browser, the application is going to be routed to an AWS application load balancer based ingress controller, and our ALB, which is actually controlled via this ingress controller, and it's going to have 3 ingress rules. The first one is /insert, which is forwarding the traffic to the backend service. Then we have another URL in the same backend service for /data. So our backend service has 2 different routes which can be used by ingress controller to send the traffic to, depending on the path that the user is trying to access. Then we also have another path which is for the front-end service. So we have, in total, we have 3 rules in our ingress configuration. I'm going to show it to you as well. Now, whenever the traffic is going to the front-end service, we have our front-end service which is forwarding the traffic to our front-end deployment. So behind the deployment, we have 2 pods running for the front-end application. So this is how the traffic will be routed from our front-end service, which is a cluster IP service, to front-end deployment pods. Then the traffic is being routed to the backend service. So we are using a Python Flask API application. Okay, so that's going to be our backend application. So once again, we have a backend service and we have the deployment to which the traffic is forwarded, and at the end, it's going to be forwarded to the backend pods. In the backend endpoints, so as I mentioned, in backend we have 2 different routes. So /insert means that insert the data into our PostgreSQL database. So we also have a database deployed via StatefulSets in Kubernetes. So so whenever the user uses this /insert path to access the website, it's going to insert the data into our PostgreSQL database, and whenever the user uses /data, then the data will be fetched. So whatever data has been inserted using /insert path, the data will be fetched with a /data URL. Okay, so these 2 routes I have configured in my backend application. It is a Python Flask API application. Okay, I'll show you everything, but I just want to explain the entire traffic flow and the application resource map. Then the backend service is going to talk to the StatefulSets based PostgreSQL database. We are using this headless service to expose our StatefulSet pods for our PostgreSQL database. And if I talk about the exact request flow, so as I mentioned, whenever the user accesses /insert, what it's going to do, the traffic is going to flow from the browser to ALB and then to the backend PostgreSQL using this insert. Okay, which means that insert the data into a PostgreSQL. Then if the user accesses a /data path, that means the request is going from browser to ALB, then to backend, and then it's going to select the data. So basically it is to fetch the data from a PostgreSQL. So these 2 routes are there in the backend Python Flask API application. And if the user uses just the raw website, then the traffic will be routed to our front-end application, which is actually an Apache web server. It is just a website in Apache which is going to serve our front-end content. Okay, so we already know that in StatefulSets we can get the stable identity of the pods, we can get persistent storage, and the deployment is always ordered, so you use this ordinal index. So the first pod is always going to be Postgres 0 pod, and then Postgres 1, and so on. Okay, so whenever we're using stateful sets, we know that we have a persistent volume claim behind the scenes. And if we are using dynamic volume provisioning in Kubernetes to create our volumes, in that case we do not have to create a persistent volume. We just need to create a persistent volume claim, and whenever any pod needs the volume, then the storage class is going to create the PV, and the PVC is going to be bound to that PV. And since I'm using AWS EKS cluster, so physically the data is going to reside as part of the volume inside an EBS volume. Okay, so this is where the data will be persisted in AWS for us. So data is physically stored on AWS EBS and survives a pod restart failure. So this is like a persistent storage, or you can say you have a persistent database that's going to be there even though your pods are failing, terminating, or crashing. It doesn't matter. So this is the entire application resource map. Let's now understand how the application is going to be deployed. So we will see the entire code and all the configuration that I'll be using to deploy this entire resource map, and then I'll show you how to access the application and how to verify the rules that we have created in our application. So here I am on my Visual Studio IDE, where I have all the different configuration files that I'll be using to deploy this application. So I'll start from the cluster part. So I am using EKSCTL to create an AWS EKS cluster. This is the standard configuration. So I'm getting this cluster config YAML file, which I'll be using to deploy my cluster named EKS app in US East 1 region. And I'm using 1.35 version. I'm using a default VPC. So I'm using the default VPC in US East 1 region in my AWS account to deploy. And I'm using two subnets, two public subnets in US East 1A, US East 1B. So just ensure that you are changing these to your VPC and your subnets. Okay, so this is from my AWS account. So this needs to be replaced. Then I'm using a managed node group as part of my EKS cluster config, where I'm getting the node group name EKS app-ng. Instance type I'm using t3.small. It may not work if you use a t3.micro because it's a 3-tier application. We're getting multiple pods, so resources may not be sufficient if you use a t3.micro. So you can use a t3.small here. And I'm using, I'm keeping desired capacity to 2. So it will be a 2-node cluster. The maximum size can go up to 4 if you're using any cluster autoscaler. Okay. And then I'm using this a public key name as SSH. So if I have to log into my worker nodes, I can use this key. I already have the private key pair named SSH, so I can use it. And I'm enabling AWS Load Balancer Controller, EBS. I'm enabling CloudWatch. Okay, so these are going to be my add-ons in the cluster. Okay, so I have already created the cluster using EKSCTL command. So for example, you can use this command EKSCTL create -f name of the file that holds your cluster config, which is cluster.yml, and I have a 2-node cluster. Okay, so it's a 2-node cluster running, and also I'm enabling I think I've already enabled OIDC in my cluster config, but in case you missed out in your cluster config, you can run this command. Just ensure that you use the right cluster name and the region where your cluster resides, and it's going to enable OIDC. I'll be using the AWS EBS CSI driver because I'll be using volumes. So I need this to create the volume using EBS service in AWS. So apart from that, I also need to create an AWS load balancer. So I'm using the standard steps where we educate the IAM policy first. So this is the command that you can use to download, and then you can create the IAM policy, which is required by your load balancer controller. Then you need to create the IAM service account that's going to be used by your load balancer controller pods. And then I'm going to install it via Helm repo. So these are standard steps that you can find anywhere. So I'm using Helm to install it inside my AWS EKS cluster. So I'm going to add the repo first, and then I'm going to update the repo index, and then I'm going to install it via the Helm chart. Okay, so ensure that you are using the right cluster name. Also, you have to use the right account ID also when you're running this particular command. So this is a placeholder. Just replace it with your AWS account. Only then this command is going to work. And then I'll just see whether all the pods are running or not. So I've already done that because it takes some time to get the cluster and like set all the things. But I just explained like why we are using this, because we need to use multiple features of our EKS cluster. So for that you need all this. So after you have done all this in sequence, just ensure that you're following the right sequence, and then you can just verify whether all the things are up and running for you. So these resources are going to be deployed in the kube system namespace. So you can check all the pods. So AWS load balancer controller is going to run as a pod inside kube system namespace, as is your AWS EBS CSI driver, which will be used to create the volumes. So you can see everything is up and running for me. Load balancer controller, a CSI controller, CSI node, and I also have a matrix server. So if I have to use HPAs, then I can use this cluster as well. Okay, then to deploy my application, I'll be using one different namespace. So I've created the demo app namespace already. So you can do kubectl. So you can run this command, kubectl create namespace demo-app. It's going to create the namespace for you. So this is the namespace that I'll be using to deploy my 3-tier application. Now I'll talk about how to deploy the application. So whenever you are deploying the 3-tier application, you always start with your database config first. Okay, so the database should be the first service to come up, then your backend, and then your frontend. This is how the sequence should be followed, so that there are no failures, okay, when deploying the application. So I'm using a config map here, which will be used by my backend pods to connect to the database. So to connect to the database, the backend pods need DB host, DB port, and DB name. So this is where it's going to connect. Apart from the config map, I'm using a secret as well. So this is going to be the secret to your database. So I'm using Postgres database here. So your username and password is going to be this. So once again, this is only a demo setup. I'm using this secret.yml, but in real world, you'll be using a password manager, or maybe in AWS, you can go for AWS Secrets Manager. But here, I just want to explain the concept of how to deploy the application with 3 tiers, and how to just understand the entire traffic flow. Okay, so this is just for the demo things that I'm using this type of secret, but in production you won't use it. Okay, so the first thing I'm going to create the config map, then the secret, and then I'm going to create my Postgres StatefulSet. So I've already done that. So this is the configuration, standard configuration only, where I'm using the PostgreSQL database. And there was one issue which I was working on related to this environment, so I have applied the fix. So you see this fix here, so it's not important, you can get rid of it. So I'm using this StatefulSet. It's using Postgres image, Postgres 14. It runs on port 5432. I'm using the secret that I've created previously. So it's called db-secret, and I'm also setting resource request and limits, and I'm mounting the volume that's going to hold my database inside. So this is the path where I'm going to mount the volume, and I'm using this volume claim template. So this is my PVC, where I'm defining like what type of storage I want to use. I want to use GP2 storage type. I want to keep the access mode to read write once, and I want to have 5 GB of storage here. Okay. Then after you, so if I just show you as well. So kubectl get sts-n demo-app. So as I mentioned, I've already deployed it to save time, but you can just run a kubectl apply command. So just start with kubectl apply-f config map, then kubectl apply-f secret, then your Postgres StatefulSet. So what I'll do is I'm going to make the steps also to deploy the application here. So here you will find exact steps in sequence how to deploy this application step by step. Okay, so I'm going to ensure that I have those steps as well listed. So you can see I have this STS running. So 1 out of 1 pod running. You can also check the pod. So I have other pods as well. Okay, so my Postgres pods are running. There's only 1 pod, so it's in running status. So after you have created your Postgres pod as part of your stateful set, then you're going to expose the stateful set pods with your Postgres service. Okay, so you can click here, you can see. So I'm using the headless service. So whenever you're using stateful sets, you have to use the headless service, which means that the cluster IP value should be set to none. Okay, so I'm using the headless service. So I've already created this. You can check the service as well. Postgres headless service is running. Okay, so then I created my backend service. So let's talk about backend as well. So this is my backend application. It's a Python Flask application. So as you can see here, okay, so I'm using 2 routes here as I mentioned in Ingress config. So this is where it's coming from. So /insert means that you have to insert the data into a PostgreSQL. So here I'm using some standard pSQL commands, and then when the data is inserted, you will see this message on the screen, which means that the data was inserted. Then to fetch the data, you have this /data rule here. So it's going to fetch the data from the database. Okay, that's all it's going to do. Here I've defined 2 routes. So I'm using these 2 in my Ingress configuration. Okay, so route number 1, route number 2. And the application is going to run on port 5000. So this is my main application. So using which I created a Docker file. So the first thing is you have to create a Docker file to create the image using this app.py file. So this is my Docker file here. Okay, so I've already created the image and I pushed it to my Docker Hub. If you want, you can use the exact image. You don't have to create the image now because I've already created. Let me show it to you. Also do Docker images here. So the image that I'm using is this one. So this is the image that I'm using. Here also you can find this one. So this is the image that I have just pushed here. So you can use the same image. It's a public repository, so you will be able to use it. But if you want to create your own image, feel free to do so. You can use this Docker file and app.py file to create your own image and push to your own repository. It can be any repository. Here I'm using Docker Hub, but it can be ECR also. Okay, so this is about our backend. So this is about our backend, and if you just see, let me just list out all the resources in the demo app namespace. So, demo -app namespace. So I have already created the front-end deployment. You can see front-end deployment 2 out of 2 running. So 2 pods are running for front-end. And similarly I have 2 pods for backend as well. So I created the backend pods first and then the front end. Okay, so backend I just explained. Let's see the front end as well. So front end is a simple Apache web server application. So frontend.yml. So in frontend.yml I'm using an image that I've dedicated a long time ago. It's an Apache web server image. It's going to create a website that looks like a travel website. So you can use the same image. You don't have to create a Docker file again. Okay, so you can use this as it is, and it's going to view, it's going to be like a real world a travel website, which I'm going to show you next. So this is how I've created the all the components. Let's talk about Ingress as well. So Ingress, you know that whenever you want to create an application load balancer that's going to be using that's going to be running as an Ingress controller, you have to get an Ingress resource. You cannot get an ALB using the standard load balancer type of service in Kubernetes. So you have to use Ingress to create an application load balancer here inside your Kubernetes cluster in AWS. So this is how you do it. You mention the main notations here, alb.ingress.kubernetes.io/scheme. So I'm using internet facing because I have to access the application from my laptop. So I'm using internet facing, and the target type is going to be IP. So here if you see, so I was talking about the 3 rules. So here are the 3 rules. So I'm using HTTP rules. Okay, I don't have an SSL certificate, so I'm using HTTP rules. And you can see in the under paths you have 3 paths. Slash insert, it's going to be the traffic will be routed to the backend service on port 80. If it is slash data, again it's going to be forwarded the traffic. I mean it's going to be the backend service where the traffic is going to be forwarded on port 80. But if it's just the raw website without any specific path, then it's going to be forwarded to the front end on port 80. So we are using 3 different URLs. 2 URLs are part of the same service, so this can be achieved using Ingress. Okay, and this last path is for the front end Apache web server. Okay, so this is how our application is configured. Okay, so our entire application is up and running. I can also show you the Ingress kubectl get Ingress. Ingress is running, exposed via an application load balancer. Okay, so now let's see how to access the application. So to access the application, we will just use this endpoint, and I'll go here. Let me reopen it. So this is my application. So this is the front-end Apache web server that I was talking about. So this is looking like a real-world travel website, but it's running Apache web server. Okay, so this is how you can access. So this is the main default path without any specific URL. Okay, so when the user accesses this in the browser, he is going to see the front-end application served by an Apache web server. But if the user adds anything, for example, user adds insert, so it's going to insert some data into my database. So when the number of times I click here, it's going to add one more line to it. And if you see the data that I'm inserting, it is any, I mean, it is some random data only, but how the data is coming, I'll just show you that part also. So here, if you go and if you go to app.py again, here you can see the data that's going to be inserted is this hello from Kubernetes. So you can change it to something else also. Okay, so I'm getting this response data inserted into PostgreSQL. It's from this return statement here. So this is the data that I'm inserting each time I click on this refresh button. Okay, and then how to retrieve the inserted data? You just need to replace this insert with data to fetch the data from your PostgreSQL database. So you can see how many times I've done it. I've done it 11 times. So it's coming like that. Let me open it again and let's go to insert. So here I have insert. Here I have slash data to fetch the inserted data. So here, if you hit refresh here, and if you hit refresh here, you will see one more entry here, which is the 12th entry and 13th. Okay, I did it like twice. So if you hit again, hit refresh here, you will see one more entry here. So this is the way the data is being inserted into our PostgreSQL database. Now how to check the database is actually there? So that also you can check. You can just use the psql commands for that. So what I'm doing is I'm executing into my PostgreSQL pod. Okay, so this is the way you exec into PostgreSQL pod here, and I'm using this psql-u admin, which means that I want to run I want to use psql CLI tool using a username admin. Okay, so I'm logged in with that, and then if I run the list of databases, if I want to see the list of databases, you will just do \l. It's going to show you the list of databases. Let me do that again. So \l is going to list all the databases that are there. So the database that I'm using here is a Postgres. Okay, so to use that, you do /c Postgres. Okay, so to switch to Postgres database, you do /c, then the name of the database, which is Postgres. Okay, so now I'm using Postgres database as admin user. Okay, now how to retrieve the information? So you have to run this command /star from demo. So you can run this command. So you can see the number of rows are coming as 14. Okay, but if I just hit refresh again here on the insert, hit refresh. Here you can verify fetch 15, and here also you can see the same thing. If I just repeat the command, you will see one more entry here. So this is how the data is inserted into the PostgreSQL database. So you can see the entire flow We are using Ingress resource. We are using ALB Ingress controller, ALB Ingress controller, and which is forwarding the traffic to two backend URLs and one frontend URL, and the data is being persisted to PostgreSQL database as well, which we just see. Okay, and yeah, so this is the entire traffic flow and the application resource map that I wanted to explain. As I mentioned, the entire code for this project is going to be put in a public GitHub repo, so you all can access it and try to do it. Have any doubts, any issues, you can reach out to me. Okay, so I think this is going to be a very good project to understand that the different resources that are there in Kubernetes, and especially we are using AWS EKS, the way the company uses to deploy this type of application, and we are also able to understand the entire traffic flow using Ingress here. Okay, and also we are able to understand the stateful sets, how it works, how it is used to process the data into a real database like Postgres, and how to see the data as well. I think this is going to give you a very good understanding if you are able to replicate this in your own environment. Alright guys, that's all I wanted to cover. If you like this video, then I do have other videos as well on my channel. I do have DevOps and SRE interview question and answers. I have some other project based interview. I have a lot of real world enterprise architectural videos, so you can go check that out as well. So it's going to help you a lot crack any DevOps and SRE interview. Have any doubts, any feedback, anything you want to ask, you can always reach out to me in the comment section or on my email ID. Alright guys, that's all, and I'm going to see you in the next one. Bye for now.